Some whales don't have teeth. Instead, these Mystacete whales have something more like a giant comb made of hair that they use for taking giant mouthfuls of small animals out of the water. I'm talking, of course, about baleen. But others, the Odontocete whales, still have rows of teeth like their ancestors did, which they use for hunting individual prey like fish and squid. That's two wildly different strategies for feeding within the same relatively small group of animals. So that presents us with a mystery. How did whales go from one to the other? How did baleen evolve from teeth? But what if I told you it didn't? And more than that, what if I told you that the gap between teeth and baleen was really nothing at all?
Nothing at all. Nothing at all. Nothing at all.
If you're watching this, you've probably at least heard about the evolution of whales back into the water, starting with animals like Pakicetus, which were able to live both on land and in shallow water, hunting a mix of vertebrate and invertebrate prey across both habitats. But as that evolution continued and whales became more fully invested in life in the water, they slowly started to reduce and then eventually completely lose their hind legs. Not the only thing they would lose that makes them weird. By around 10 million years later, animals like Durodon and Basilosaurus were most likely fully aquatic, confined to hunting aquatic prey. This was still being done with toothed jaws used to actively bite and capture their targets. Basilosaurus in particular seems to have been able to exert an enormous bite force, likely taking the spot of apex predator in the oceans of their time, even preying on other early whales like Durodon. That strategy persists to the modern day, 50 million years after Pakicetus, in animals like the orca. It's hard to imagine an animal like that becoming toothless. The teeth of those early whales were probably not too different from ours, at least in terms of how they develop and the substances they're made of. They're made of enamel just like ours and those of all other mammals. Baleen, on the other hand, is completely distinct. It's made of keratin, the same stuff as hair and nails, and rhino horns, just to name a few examples. From this alone, we can see how profoundly different these two structures really are, at a chemical and developmental level, far deeper than just the hunting and feeding behavior that they're used for. Clearly, they're just so fundamentally different that one couldn't have just simply evolved from the other. So our question of how whales transitioned from teeth to baleen seems to need another explanation. Lineages of whales persisted with teeth, but as time went on, members of the baleen lineage of whales started to appear with reduced teeth, either smaller teeth or fewer teeth, or in some cases even highly modified teeth, possibly mimicking the filtering systems that would evolve later. You might expect this to be some sort of gradual transition, like the one that whales undertook when they returned to the seas. Perhaps even a whale with some sort of bizarre mix of both teeth and baleen. And certainly some scientists expected to find those kinds of intermediary forms. But whether or not they really exist is a matter of strong and ongoing debate in the scientific community. This was a mystery, but now we have a fossil that falls in that gap in the fossil record. And the reality it shows is extremely surprising. Between teeth and baleen was nothing. Whales first completely lost their teeth and then evolved baleen later, possibly millions of years later. In the gap in between, toothless whales swam the oceans. And that might sound crazy, but this fossil, Maya balena, clearly shows the skull of a whale with neither teeth nor baleen. This animal probably fed using suction, using strong facial and throat musculature to suck in prey, similar to what some fish like salmon still do today. The first truly confirmed baleen-using whales in the fossil record, with actual fossilized baleen, are from the Middle Miocene era of Peru, living around 11 to 16 million years ago. and they're just a glimpse of what was to come. Since their origin around 36 million years ago, the baleen lineage of whales has continued to persist, even through their strange toothed and toothless stages. They now encompass about 14 living species, depending how you count them, including some of the largest animals and the largest animal to have ever lived on Earth. Strangely though, when you look at the embryonic development of these giant modern baleen whales, you can still see a toothed stage. The embryo will first develop teeth and then reabsorb them into the bone of the jaws, before then growing baleen from the palate and gums of the upper jaw. This is a clear example of the development of the animal giving snapshots into its evolutionary history, something that we can see all across the animal kingdom, even in us. Early human embryos have gill slits reminiscent of our truly ancient fish and fish-like ancestors of the Paleozoic epoch. All of this leads to another question. Why? Why any of this? We've talked broadly about the history of the transition from teeth to baleen, but that by itself doesn't inherently tell us anything about what might have led to that striking and unique transition. As with everything I talk about on this channel, we need to consider the influence of natural selection. What advantage does baleen filter feeding give to the animals that do it? Thankfully, that question is relatively easy to answer. It's all about efficiency and energy economics. Using baleen, they are able to harvest absolutely vast quantities of small animals from the ocean, things like krill and plankton. Those food sources represent an absolutely huge chunk of ocean biomass that is just not available to other whales. And more than that, they tend to be quite densely clustered, meaning that they can be harvested very efficiently in huge mouthfuls. In fact, some estimates say that baleen whales are able to consume up to 450,000 calories in a single mouthful. For context, it would take me about 6 months to eat that much. As the saying goes, you've got to eat big to be big. Their huge size actually compounds that. Being bigger means bigger mouths, and bigger mouths means bigger mouthfuls. And also bigger lungs means longer and more extended diving sessions, giving them more chances to find food and take those bigger mouthfuls. However, we should say gigantic whales did exist long before baleen filter feeding. So clearly they do have other routes to become huge, but undoubtedly the ridiculous energy gathering efficiency of filter feeding has helped them to maintain their current enormous sizes. What I think makes this story really interesting is not just that whales lost their teeth and then evolved baleen. It's about how that happened, not as a smooth and gradual transition from one structure into the other, but as something more like a complete reset. Teeth disappeared completely first, and for a time in the middle, there were whales managing without either structure, relying on something else entirely. Only then did baleen emerge, possibly millions of years later, developing in a completely different way and made of a completely different substance, yet still solving the issue of feeding, but from a completely different angle. Maybe that's understating it. Baleen whales aren't just a bit different from their toothed relatives. They occupy an entirely different ecological role as engineers of the ocean ecosystem. One not built around hunting individual prey, but rather harvesting and processing enormous volumes of the ocean itself. So really, when we ask how whales went from using teeth to using baleen, we're asking a much bigger question. Not just what changed or how it changed, but rather why it changed and why that change has stuck. We've already talked a bit about energy and feeding efficiency, but there is another broader answer, and that answer, as it so often is in evolution, is about what works. Maybe not perfectly, and almost certainly not permanently, but well enough in the right place at the right time to reshape an entire lineage, from predators with teeth to giants that filter the ocean. And somewhere in between, briefly and a little strangely, neither. If you found this interesting, there's lots more where that came from. I make videos about strange cases in evolution, where things have evolved more than once or have gone to extremes. If you want to find out about the evolution of caffeine or how a megacarnivore once got lost in a museum, just click the links above or below and make sure to subscribe for more like it in the future. Thank you for your time.